Welcome back to today's session, children. In the previous class, we were discussing about atoms and molecules, where we have learned how atoms will combine to form a compound, where we have learned about laws of chemical combination. In that, we have understood about two different laws, that is law of conservation of mass and law of constant proportion. Today, we shall learn about history of atoms. Uh, a famous scientist, that is John Dalton, a British chemist, in the year 1808, on the basis of studies and investigations carried out by Dalton, he came out with a statement that the smallest portion of matter which cannot be further divided is said to be an atom. So, what he says, according to him, whatever the matter we see around us, it is made up of undivided particle which is called as atom. And atom is ultimate, which cannot be further divided. And he gave a famous theory which is called as Dalton's atomic theory. What is the Dalton's atomic theory says then? It is also called as postulates of Dalton's atomic theory. His first famous atomic theory says that every matter is made up of very small particles known as atoms. That means any matter, whatever the substance see around us, it is made up of atom and which cannot be further divided. See, if you take the picture, first picture where the pencil, if you go on zooming it, finally we will get the last particle which is called as, or dividing it, the last particle or the finest particle, what we call it is said to be atom. And that means everything, the whole pencil is made up of only atoms. This is what he says. So this is how the atom is present. And he has given many postulates where atoms cannot be further divided, and atoms of different elements have different mass, size, and also chemical properties. Say, he says that atoms of different elements, say this is the first hydrogen atom, its size and mass is different with different atoms. Like hydrogen atom, this is oxygen atom, this is carbon atom, we have sodium atom, chlorine atom, and uranium atom, where all these atoms are the atoms of different elements, and they have different mass and size and also different chemical properties, because uranium shows different chemical properties, atoms of chlorine will show different chemical properties, sodium atom of sodium will shows different chemical properties, like that. He says that atoms of different elements have different mass means it's how much it weighs, and size are different here, and also chemical properties. Like this, he has given his postulates. And also he says that atoms of same elements of different elements combine with a small whole number with the ratio to form molecules of a compound. This means uh, if you take atoms of same element like hydrogen, first you can take hydrogen one atom and set two atom. It is combined to form. It is combined to form a molecule here. So molecule means more than one atom. If it combines, two or more atom combines to form a molecule. If molecule is formed by the atoms of same element, it is said to be molecule of an element, and it is combining in the form of small whole number. Here there are no fractions, no decimals, it is in the form of whole number, that is H2. If you take oxygen, here also oxygen atoms, only two atoms will come. That's why we will write always O2. O2, why we will write O2? Because always oxygen will be in the form of two atoms. There two atoms have combined to form oxygen molecule. Here chlorine atoms are there to form 2Cl2, that is chlorine molecule. Here we have three oxygen atoms, that is O3. O3 is also called as ozone. So this is oxygen molecule, another oxygen molecule. In the same way, we have sulfur. There are 8 atoms here. So it is the molecule of only sulfur element. Here, the atoms have combined, atoms of same elements have combined to form the molecule of that element. If you take molecules of different elements like hydrogen H2 are there here in the first one, and it has combined to one oxygen atom. Then it is said to be H2O, which is a molecule of water compound. And the second one, if you go with the second one, there N, one atom is there. N is nothing but nitrogen, and 3 hydrogen atoms are there. So NH3 is the formula for ammonia. So this is also a molecule of a compound where 2 different elements are present here. If you come to the next one is carbon compound atom is there, and 2 oxygen atoms are present here to form CO2, which is the formula for carbon dioxide. In the same way, we have 1 carbon atom and 4 hydrogen atoms to form methane, that is CH3. Like this, molecules will form by the combination of 2 different atoms of different elements. It can be more than 2 elements also, where to form the molecule of a compound. It is said to be a molecule of a compound. Then moving on to the limitations or drawbacks of Dalton's atomic theory. We have understood about postulates. What he says that atoms cannot be further divided, and every matter is made up of um, atoms, and the atoms of different elements have different mass, size, and everything. All these are the postulates of Dalton's atomic theory. Now moving on to limitations. Limitations means what are the drawbacks. Later on, after when he discovered about atoms, there are many other scientists who has discovered regarding more about atoms. That first most drawbacks of his postulate is atoms have been found to made of subatomic particles. That means atom is not at last. He says that atom cannot be further divided, but you know that atoms are made up of subatomic particles inside it. They are called as electrons, protons, and neutrons. So atoms are made up of electrons, protons, and neutrons. And atoms of same element have say different masses. He said that atoms of same element have same masses, but we have different masses also, and they are known as isotopes. Regarding isotopes, you will learn in the further classes, children. So atoms of different elements may have same masses, and they are known as isobars. Regarding isotopes and isobars, you are going to learn in the further classes. And atoms of different elements may not always combine with simple whole number ratio to form molecules of a compound. So these are the limitations or drawbacks of Dalton's atomic theory. Regarding the limitations, you are going to learn in the further classes, because these were the limitations which was given by the other scientists. And regarding the isotopes, isobars, and all, you are going to learn in the next classes. So next is atom and atomic number, which is a very important concept of this chapter. What is atomic number? You know that atoms means the smallest particles of elements. So atomic number is very important. And what is atomic number? It is defined as the number of protons present in the nucleus of an atom. It is denoted by Z. So atomic number means it can be number of protons or number of electrons, we can say. So in an atom, if you take an atom, there will be a nucleus. The center part of an atom is said to be the nucleus. And inside the nucleus, we can find 2 subatomic particles. What are these 2 subatomic particles? That is neutrons and protons. And together neutrons and protons is called as nucleus. And uh, outside the nucleus, outside the nucleus, there are electrons which are revolving around the nucleus. So protons, neutrons and electrons all together are the subatomic particles of an atom. Dalton said only the whole atom is a smallest particle which cannot be further divided, but we know that in an atom can be divided into protons, neutrons and electrons. Now, in the atoms, you know that number of protons are present. What is the atomic number? Number of protons. Number of protons, whichever the here if you take this picture here, blue color balls indicates protons, yellow color indicates neutrons and the red color indicates electrons. And the blue color, if you check the number, means here 1 2 3 4 5 5 protons are present. That means the atomic number of this atom is 5. Which is the which element has the atomic number 5? It is boron. So this is the atom of boron. Like this, each and every element has its own number of protons. And one more thing we have to remember here, whatever the number of protons are present, it is always equal to the number of electrons. So protons is equal to, number of protons is always equal to number of electrons, which is nothing but atomic number of an element. So each and every element has their own atomic number. That means if we take hydrogen, hydrogen atomic number is 1 because in its atom, in its nucleus, it contains only one proton. And if you take helium, its atomic number is 2, where helium atoms contain only 2 protons in its nucleus. Like that, if you take carbon, carbon contains 6 protons in its atomic nucleus, where its atomic number is 6. This indicates that atomic number is nothing but number of protons present in the nucleus, and how much number of protons are present in the nucleus is always equal to the number of electrons. And one more thing, protons always have the positive charge and electrons always have negative charge, and positive should always be equal to negative. So this is the atomic number. So regarding atomic mass and all, we are going to learn in the next class. Thank you, children.